Welcome back to another video. Today we're talking about geometric sequences and series. I already have a video on the channel talking about geometric sequence and series in terms of theory and a bit of practice, but this video is designed, as you can see from the title, for full practice. I've picked out 5 questions in different difficulty, and I hope that it will give you a good practice session. So what I want you to do is don't just watch the videos. Obviously, we don't learn math by watching. Make sure you pause the video after you see every question. Try it for yourself and then come back either for an answer or to check to see if you missed anything or if there's any better way to do it, or whatever the case is. We're looking for the most efficient way that can get us to the answer without losing much time. So whether it's your method or mine doesn't matter, as long as it's the best one. All right? So with that being said, let's start with the first problem. Consider the infinite geometric sequence, 4,480, etc., etc. Find the common ratio, find the 20th term, and find the exact sum of infinite sequence. Now, in this video, I will not explain every detail because I've done that in the theory/practice video. This time, I'll try to be a bit more quicker, and I'll use formulas assuming you're already familiar with. Again, if you're not, please go check out that video. So, consider the infinite geometric sequence, find the common ratio. To find the common ratio in geometric sequence, we take the next one, we divide it by the previous one, right? So negative 3360 divided by 4480. Okay, and if we do that, I'm going to use my calculator here. A little bit of cheating on my part. And that's going to give us negative 3/4, which is also negative 0.75. So the answer for the first part is negative 0.75. Find the 20th term. Now, we're going to use the UN for U20, right? I'm using the formula here. You can see it on the top right corner. U1, okay, U1, what is U1? U1 is 4480. We can see it from the sequence right here. Times R, our R is negative 0.75 to the power of n minus 1. What's n minus 1? 20 minus 1, that's going to be 19. And that's going to come approximately to, you can use your calculator for this, about negative 18.9. That's U20. Negative 18.9. So you can see, because R is a negative value, well, actually not because R negative value, R is a value less than 1, our value keeps getting smaller and smaller, but it switches between negative and positive. Okay? And last part, find the exact sum of infinite sequence. So we're using the formula that we have here for infinite sequence. And how do we know if it matches the criteria? Because absolute value of R is less than 1. So absolute value of R is, in our case, is 0.71, and that's less than 1. So we can use this sum formula. So S infinity is going to be equal to U1 for 480 divided by 1 minus negative 0.75, whatever that is. So 480, this is 1.75, right? And that's going to come to 2560. You can use your calculator to find that answer, 256 and 0. A geometric series has a common ratio of 3 to the power of x, meaning R is equal to 3 to the power of x. State the domain of x such that the sum to infinity of the series exists. Now, from the sum to the infinity formula, we see that R, or absolute value of R, needs to be less than 1. It needs to be less than 1. And well, for it to exist. So the absolute value needs to be less than 1, but the actual value itself, meaning R, needs to be between negative 1, R, which our case is 3 to the power of x, less than 1. Now, a little bit of a cleanup here. At no value of x, at no value of x, 3 to the power of something can be a negative value. So we can do a little update here. There you go. This is what we need to solve, again, because there is no x such that 3 to the power of that value is going to be negative 1. Okay? Now, we're looking for what? Domain of x such that this exists. So let's look at this graph here. I put a graph here. You can use your calculator or decimals to graph it, but in the exam you won't have decimals, so you can use your calculator. And you can see that the value of this function, which is y equal to 3x, is increasing function, right? It comes from negative infinity and it goes to positive infinity. Yes, negative infinity to positive infinity. But you can see that after x is 0, so when x is 0, the y is 1. After this, the value of y becomes greater than 1. Greater than 1, meaning 3x is greater than 1, greater than 1 when x is greater than 0, which is not good for us. We need it less than 1. So less than 1 is everything remaining. Okay, so this part here, it makes it bigger than 1, but we want less than 1, so we're going to stick with x less than 0. So that's going to be our answer for A. Let me write A here. Okay, take your time. Again, domain of x mean, if you are not familiar with what domain is all the possible values that x can get such that this equation that we have here, or inequality rather, is correct. Okay, think about that a little bit. It might not be obvious at first. B. The sum to infinity of the series is found to be 54. If the first term of the series is 52, find x. Okay, this should be a bit straightforward. We have the sum to infinity formula. So 54 is given, is equal to, u1 is given, 52, 1 minus, and we know our r, which is 3 to the power of x. We can do a bit of a cross multiplication here, probably, right? And say 54 minus 54 times 3 to the power of x is equal to 52. Let's keep x's in one side and numbers in one side. So 54 times 3 to the power of x is going to be equal to 2, right? And 3 to the power of x is going to be equal to 2 divided by 54, which is also 127. And 127, if you know your exponents, can be written as 3 to the power of negative 3. So we've come to the final decision step. 3 to the power of x should be equal to 3 to the power of 3. The bases are same, which means the exponents should be the same as well. So x is going to be negative 3. A tennis ball bounces on the ground n times. The heights of the bounces h1, h2, ... hn form a geometric sequence. A geometric sequence. The height that the ball bounces the first time is 80 centimeters and the second time is 60. Find the value of the common ratio of the sequence for the sequence. So we're looking for r. Now, we know from geometric sequence, r is equal to next term divided by previous term. So 60 divided by 80, because 60 is second and 80 is the first one. And that's going to be 6 divided by 8, and that's going to be 0.75. So A is going to be 0.75. Find the height that, okay, this is A. Now B. Find the height that the ball bounces the 10th time. So h10. We know h1. We know r, right? What's r? R is common ratio, which is 0.75. So we're looking for now h10. h10. Basically, we're looking for u10, right? Now, what's the formula? u1 times r to the power of n minus 1. You can see it here on the top right corner. U1, what's U1? 80, right? Times R is 0.75 to the power of n minus 1. N is 10, 10 minus 1 equals to 9. So if you use your calculator, you'll get an approximate value of 601. So as the ball bounces, the bounce becomes smaller and smaller, probably due to gravity, right? And the last part, so this one, 601. And the last one, find the total distance traveled by the ball during the first 6 bounces up and down. Give your answers correct to 2 decimals. So we're looking for basically Sn here. Sn and how many bounces? 6. So we're looking for S6. So since this is a finite, we're looking for 6 bounces. We're going to use the second formula here. We can use either variation. It doesn't matter. As long as we know our R and U1, then we're golden. So what's our U1? Is 80. R is 0.75. To the power of n, n is 6 minus 1 divided by R minus 1. 0.75 minus 1. Okay, you can use your calculator here. And this is going to give us some sort of value. But we have to be careful here because it says first 6 bounces up and down. Up and down. So whatever value we get from it, from this exact equation, this is either going to be up or down, right? And then to find the total distance, we just have to multiply that value by 2. So basically we should find 2 times S6. I'm going to keep the 2 here. And that's going to give us approximately 526. Again, you can use your calculator here. So this part is a bit tricky about being up and down. So whenever we read these problems, we have to be very careful of what they're asking for. And they kind of put it into bracket, kind of show us that, you know, this might be an important thing to notice. The third term, U3, of an arithmetic sequence is 7. I know this is an arithmetic, but it has a geometric part to it, so let's work on it, and it will be a good reminder of arithmetic as well. So U3 is equal to 7. What's U3 for arithmetic? Does anybody know? If you remember the formula, U1 plus 2D is equal to 7. The common difference of the sequence D is 3. So if D is 3, I can plug it in here and find my U1, and that's going to be 7 minus 2D, which is 7 minus 2 times 3, 6, 1. So I know my difference and I know my U1. Oh, they were asking for U1. So U1 is 1, basically. I didn't even read part A. B, find U60, the 60th term of the sequence. Easy. How easy? Because we can just say U60 is equal to U1 plus 59D. And that's going to be equal to, U1 is how much? 1 plus 59 times 3. I'm not sure what that is. 59 times 3. Let's see. 59 times 3. 177 plus 1, 178. So 178. And now we come to the last piece, which is geometric. The first and fourth terms of the arithmetic sequence are the first 2 terms of a geometric sequence. What does that mean? So the first and fourth terms of this arithmetic sequence are the first 2 terms of geometric. So we have, let's say, U1, U2, U3, U4. This is my arithmetic. and I have u1, u2 in geometric. So it says first and fourth, so this is first, this is fourth, are the first two terms of the sequence. So u1 is equal to u1, basically, respectively, and u4 is equal to u2. Calculate the sixth term of the geometric sequence. So we already know what our u1 is, which is 1. And if we can find the u4, that means we'll be able to find the u2 of geometric. So u4 is going to be equal to u1, which is 1, plus 3d. d is 3. 3 times 3 is going to be 9, 10. So the total is 10. I don't know if you can see that actually. There you go. Now, this is 10. So we know that geometric sequence, first term is 1, second term is 10. So it seems like r is going to be what? How do we get from 1 to 10? By multiplying it with 10. So our r is going to be 10, right? And we need to find the sixth term of the geometric sequence. That's going to be u6 is equal to u1, which is 1, times r, which is 10, to the power of n minus 1. 6 minus 1 is 5. So the answer is going to be 10 to the power of 5, which I don't know what that is. 1 followed by 5 zeros, I guess. Yes, 100k. The fifth term, u5 of a geometric sequence, is 125. The sixth term is 156.25. Find the common ratio of the sequence. So u5 is equal to 125. u6 is equal to 156.25. To find the common ratio, so a, all I need to do is divide u6 by u5. That's going to be 156.25 divided by 125. That seems to be a bigger number than 1, and it is. It's 1.25. Okay. B, find u1, the first term of the sequence. Now that we know our r, we can either use u5 or u6 to find what u1 is equal to. So u5 seems like a smaller number, so I'm going to go with that. u5 is equal to 125, and that's equal to u1 times r, which is 1.25, to the power of n minus 1. n is 5. 5 minus 1 is 4. So u1 is going to be equal to 125 divided by 125 to the power of 4. And if you use calculator, you'll get a value of 51.2. So that is u1. C, calculate the sum of the first 12 terms of the sequence. If we know our u1 and we know our r, common ratio, then it's easy. Our absolute value of r is greater than 1, so we're going to use this formula right here. And that's going to be S12, because we're looking for 12, n equal to 12, is going to be equal to u1, where's u1? 51.2 times 1.25 to the power of n, which is 12, minus 1, divided by r minus 1. 1.25 minus 1. Again, if you use your calculator here, you'll get a value of 2780. 2780. All right? So, all right, thank you for tuning in. I hope you enjoyed the video. These practice videos are designed only for practice, so I might be going a bit faster on these ones because I assume that you've already checked out the theory part and you're familiar with simple terms, so I don't explain every little detail. If you want a bit more explanation, make sure you check the theory videos. And if you have any suggestions or things that you would like to see, please do let me know in the comments. Other than that, if you find it useful, consider liking and subscribing to the channel. I'll be posting a lot more videos for IB, AA or AI, HL or SL exams as we get closer to exam time and during the whole academic year. Okay, with that being said, I'll see you guys in the next one. Fuck's sakes, mate.